is the inclined planes. That's the last things on inclined planes. There is one more, which is a resisting medium that I can cover in the next class, and inclined planes. So, in inclined planes, inclined plane is this. All right, this is an inclined plane. So, imagine that we have an object on this inclined plane like this. Like this, right? It can accelerate or it can be at rest, either way. So, because there is no friction, this goes without friction. Because there is too much friction, which is not overcome, so we have this in this situation. This have multiple applications in everywhere. In engineering, you can see that every screw has inclined planes in the threads. So the theory of the screw and all this is based on the inclined planes, on this theory we are now learning. So inclined planes, for instance, if we have an incline like this, and this is what we will call the angle of the incline, theta. Whenever we have an object here, the forces here can be, what force will be here acting on the object? Normal force perpendicular to the surface. What else? Fg. And if there is friction, the friction will be in this direction. This is my row diagram. Important here is to draw the free body diagram. In physics, it's better to draw the free body diagram in such way that one direction or one axis coincides with the direction of motion. Why? Because if I draw the coordinate system this way, I will have an acceleration along x and along y. So it's better to have only one acceleration along x rather than to have acceleration along x and along y. What can I do? I just can decide to draw my free body diagram like this. In the direction of motion can be my x-axis. Perpendicular to it will be my y-axis. And the object can be here. The forces now I put of the origin, Fg, Fn. If there is friction, But whenever we have a force at an angle, we draw the components to be more specific. Which force is acting at an angle with respect to the axis? So I will have Fgx, this component, and this Fgy. Fgx and Fgy. So, my angle, this angle, supposedly will be here. So if I extend this just to see, and this is Fg, and the angle here, this angle, if it's 30 degrees, what will be this angle? 60. And how much will be this angle?
30.
So this is my angle of incline. So the angle of incline is from the x or from the y-axis? From the y-axis. In my theory of vectors, I said that we will use f cosine theta or a cosine theta if the angle is with respect to which axis? X-axis. So I have to interchange. So now for fgx, and remember that, some people will say, why we don't get the complementary angle? You never will remember that in a test. So the best thing is to work with fgx always in the inclined plane. Fgx will be mg sine theta, and fgy is mg cosine theta. You interchange it. Why? Because the angle is from the y-axis, not from the x-axis. It's something you need to remember. Fgx, mg sine theta, fgy, mg cosine theta. Now, knowing that, the typical question will be the same. Find the acceleration, find the velocity if it's given delta x. So, for instance, let's do a problem. Let's say that a skier goes down the hill. The skier goes down the hill. Okay? The question, given given the theta, mu, n, the mass is not given. The mass is not given. Theta, mu, find. And the time to go to this point, find A, the acceleration of the object, B, find the velocity at that time, when reach the lower point of the slope. How can I find the acceleration? Following the algorithm, tell me how can I find the acceleration. Which Newton law, first or second? Second law. So if I apply the second law, will be sigma f along which axis is the acceleration? Along which axis is accelerating? What I call x or y? So sigma f along x equal to what? ma. Is that right? What is the net force along x? From my diagram, what can you tell me about x-axis? What do you see? mg sine theta, which is fgx, minus mu k, because it's moving,
times normal force.
and the normal force in this case is along y-axis. So what will be my normal force? Here is my normal force. Look, what will be my normal force? On the y-axis we go, is moving or not? What I call y-axis is moving or not?